All right, so we are going to take a look at the school. Take a look at the school round, the school competition, the team round, and we're looking at the last 5 problems. I may make a separate video for number 10, but let's do the first 4. Are you ready?
Yeah. Absolutely.
Okay, here we go. All right, there are 3 children living in one of the 3 houses, equally spaced and arranged as shown. Each child is equally likely to live in any of the houses, and it's possible that a house has no children living in it. All 3 children will play in the house that minimizes the total distance they have to travel. What is the probability that they will play in house B? Express your answer as a common fraction. We have 3 different opportunities, 3 different situations, if you will. Option number 1. Option number 1. I'll write this. Option. You know what I mean. Option number 1. It's a pretty one, yes. Option number 1.
It's OPTION.
They have 1 person per house. So 1 person per house. That means there are no siblings. Everyone is an only child. Okay. Option number 2. Option number 2. 1 pair of parents has gone totally out of their mind and has 3 kids. That's your parents, and some other parents are even more insane. So that means we have 3 in one house and then 0 and 0 in the other 2. Now, the slightly more challenging situation is option 3, which is where we have 2 in one house, 1 in another, and 0 in the third house. So those are the 3 options that we're looking at. And we're going to look at it in this order. So option number 1, there's 1 person in each house. Now I'm going to start going a little bit faster. So how many different kids can end up in house A?
3.
There are 3 different options. So if we have 3 people who could be in A, how many people could be in B?
3. Well,
2. So the person who's in A, and then there are 2 other people left over, one of those 2 will end up in B. Now, if we have 1 person in A and 1 person in B, how many people do we have left over for house C? 1. So if we have 3 options times 2 options times 1 option, how many total options are there?
6.
There are 6 total options. Now, in each of these options, house B will be the central house because each A and C are 1 block or 1 house away and B doesn't have to move. So that's 6 of 6 options will end up at house B if we have 1 person in each house.
It's only one of the options.
Well, no, there's 6 different options, and each one of them is going to end up in house B. So let's look at the second situation, and that situation is we have 3 kids in one house. So how many different ways can I put 3 kids in house A?
3. No, 1.
1, because they're all in this house. How many different ways can we put 3 kids in house B? 1. How about here? 1 times 1 times 1 is 1, which gives us a grand total of 1 option. Sorry, right. So we have a total of 3 options because 1 they're all in A, 1 they're all in B, 1 they're all in C. How many of these options have the kids playing in house B? 1. When they're all in house B. So that means we have 1 out of 3 options if you have all of the kids in one house. Are we doing okay so far?
Yep.
All right. So now this is where it gets a little bit confuzzling. And I'm going to take more time than I would in a competition to explain it, but that's okay. So if I have two kids, how many, let's call these kids thing 1, thing 2, and thing 3. How many ways can I put 2 kids into house A? Who would be in house A? 1 and 2, 1 and 3, and 2 and 3. So I have 3 different ways of doing that. And I'm going to give myself a little more room. So that's 1 and 3, and 2 and 3. All right. So if I have 1 and 2 here, I could put thing 3 in house B, which would mean there's nobody in house C. Or I could put nobody in house B and thing 3 in house C. Do any of these options make B the house they would play at?
No.
No, because if they hang out in house A, that means you have 1 block to travel here. If you hang out in A, in this situation, you have 2 blocks. But if you go here, that's 2 blocks, right? If you go here, that's 4 blocks. Clearly, they're going to play in house A. So these situations don't work. Same idea here. We have 2 or nobody and 2. 1 or nobody and 1 and nobody. Do any of these options make house B the best house?
No.
No. And what's your job as a student?
To pay attention and make notes.
To take notes. So if you do not have a pencil in your hand, you're doing something wrong. Okay, so none of these options work. But how many options are there? 6. But, so there's 6 options this way. But I could put the 2 kids in house B. That'd give me 6 more, right? Or I could put the 2 kids in house C. Gives me 6 more. So how many different ways can I rearrange having 2 in one house? 18, 6 times 3. So we have a total of 18 different ways of doing this. Now, which option will make B the best playhouse?
If you have 2 kids in B.
If you have 2 kids in B. So how many kids in B, or how many options have 2 kids in B? 6. So we have 6 more. All right, so we have 6 options and 1 option for a grand total of
13 out of 27.
13. Out of, well, 6 plus 18 plus 3 is 27.
This is more complicated than I thought it would be. I just guessed 2 nerds.
So the key on this one is realizing there are 3 different situations. Having 1 kid in each, having 2 kids, or having 3 kids in one house, and having 2 kids, 1 kid, and 0 kids. So you have to take each of those situations as separate. Now clearly I went through that really, really slowly, but that's okay. We okay? All right, I'm going to go much faster for this next one because it is pretty straightforward, quite frankly. How many distinct positive integers n can be expressed as n equals a times b for integers such that 1 is equal or less than a, which is less than or equal to 10, and the same for b. So this is kind of a probability situation. We have a times b, and a can be something, and b can be something, and they could be the same thing, right? What's the best way to show probability if you have 2 events happening?
A tree.
Definitely not a tree. We want an area model. If it's 2 events, you definitely want to make an area model. It's much easier. So what I'm going to do is I'm going to pull this thing back down here. And we're multiplying 2 things together. And we want to know how many different products we'd get. You know what that sounds like? That sounds like a multiplication table.
Yay!
So we're just going to make a multiplication table, but we're not going to write it all out. We are going to just look for the distinct products. The distinct meaning that how many different numbers can we get? So here we go. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, I don't like that. So if I'm doing it, what are you doing? That's right. And I also have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I'm not going to have to write out 100 different numbers. There's a quicker and easier way. All right. And so if I get a new product, I'm going to write that product. If I get a product that I already have, I'm going to cross it out. Cross that square out. So what is 1 times 1?
1.
And all of these are new because I'm just starting. But now I can cross out all of these because I don't want the repeats. I know. Yes. 2 times 2 is 4. We already have 4, so we don't need that one. 6 we already have. 8 we already have. 10 we already have. 12 we don't. 14 we don't. 16 we don't. 18 we don't. And 20 we don't. I can cross that one out. So 3 times 3 is 9. We already have that. 12 we already have. 15 we don't. We have 18. Oh, we already have 18. 21 we don't. 24 we don't have. 27 and 30. And I can cross out the rest of that column. 4 times 4 is 16, but I already have 16. We already have 20. We already have 24. We do not have 28, so I'll include that. So we do 32 we don't have, 36 we don't have, and 40 we don't have. You can cross that out. For 5 times 5 is 25. That is unique. 30 is not unique. 35 is unique. We have 40, which we already have, 45, and 50. And I can cross all those out. 6 times 6 is 36, but I already have 36. 6 times 7 is 42. I don't have 42. 6 times 8 is 48. Don't have that. That's 54 and 60. Cross that out. 7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 72. No, it's not 72. It's 63. And we have 70, also unique. 8 times 8 is 64. I don't have 64. 8 times 9 is 72 and 80. Cross that out. 9 times 9 is 81, 90, and 100. And all we have to do now is add up the total numbers we have. If, with any luck, we get 42. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42.
You did it right.
Dude, I was on the right track.
You told us how to do it, and I still screwed up.
I was on the right track.
All right. Are you ready, Walter?
Yeah.
All right.
Subscribe.
So we have a guest explainer here.
His name is Walter.
Walter!
Go, Walter!
Here we go. Let's go, buddy.
Watch this.
So, do it.
There you go. There you go. Go for it.
Okay, so for number 8, we need to find the area of the shaded triangle. B, E, C. And so to find that, we need to find the height of this triangle. And from that, we need to realize that all of the side lengths are 6, and of the triangle too. So what we don't know right now, so we need to add, we know this length right here is 6 from here to here. So we need to find this length to get the height. So since this is right here is going to be half of this total side length, it's going to be 3 right here. So we know that a squared plus b squared equals c squared. This side will be c squared, and this side will be a squared. So we do 3 squared plus b squared equals 6 squared. And then, so this would be equal to 36. And then this would be equal to 9. So then we can just do train tracks. So we would subtract 9, 36 minus 9 is 27. So b squared equals 27. To find b, we would, yeah, okay. Oh, okay. So the square root of 27, is it 27 then square it? Okay, so is, it says round to the nearest tenth, so it's 5.2. So we know the side length right here is 5.2. And then we would add 6 to 5.2. You get 11. You get 11.2, and then you multiply 11.2 by 3 to get this side of the shaded triangle, and you get 33.6, and that's the answer.
All right, excellent. The only way we could have made this go faster is if we had recognized that this was a 30-60 right triangle. And so in a 30-60 right triangle, we know this height would be this value times the square root of 2, or sorry, square root of 3. So 5.2 is also equal to 3 times the square root of 3. All right. And so I'll do 9 and then I'll do 10 independently because I feel like this video is getting a little bit long. Just a little bit. I mean, almost 20 minutes, and that's the whole time you have to do this round anyways. All right, so what is the area of quadrilateral ABCD as shown? There are 2 ways you can do this. One is called the shoelace method, which I'm not going to show now, because the easier way is, well, if I just make a rectangle around this object, I can find the area of the whole rectangle and subtract out the areas of the triangles, and voila, I have the answer. So this is actually a really, really short problem. So what is the distance from -2 to 7? 9. What is the distance from -4 up to 6? 10. So this whole thing has an area of 90. Yes?
Yeah.
Okay. So from here to here, what is the height of this triangle? From -4 to 2? 6. That makes this 4. Okay. What's this distance here? 8. Because we're going from -2 all the way to 7. -2 to, wait, whoa, slow down. Wait, from -3 to 7 is not 9, it is 10. So from -2 to 7, it is 9. That means this is 1 right here. So what's the distance here? We're going from, it's 8, so from 4 to -4, so that's 8. That makes this 2. So that means this whole area of the rectangle is It's 100, it's not 90, okay. And so 9 times 6 divided by 2 is 54 divided by 2, which is 27. 4 times, oh, we need to figure out this side here. So from here to here is how far? Well, that's 3. So that makes that 7. 4 times 7 divided by 2 is 2. 2 times 3 divided by 2 is from here to here. So 1 times 8 is divided by 2 is 4. So that's 7. That's 21. 21 plus 27 is 48. So subtract 48 from 100 and you get 52.
Why are all these so easy?
We used 48.
It is always, always easier when there's no time and there's no competition. And you have somebody showing you the most efficient way of doing it. That is normal.